All right, today's lesson, we're going to be starting our factoring. And factoring is when we unmultiply, or it's the reverse of the distributive property or the reverse of FOIL. And we often do this to solve quadratic equations. And we haven't used the word quadratic equations at all this year, but a quadratic equation is an equation where the highest power of x is 2. So for example, equations need an equal sign, so y equals x squared. That's the simplest form of a quadratic. It's x to the second highest power. Y equals, so these are all examples, y equals 3x squared minus 5 quadratic. Highest power of x is 2. But this now only has two terms, one term, two terms. We could also have a quadratic with three terms, so something like 7x squared minus 2x plus 3, quadratic equation. Highest power of x is 2. Some non-examples, y equals 3x plus 2. Well, that's linear. It's not x to the second, it's x to the first. Or y equals 3x to the fourth plus 7x. Here, the highest power of x is 4, so it's not a quadratic. Ultimately, one way we use factoring is to solve quadratics, like we said. But before we start solving by factoring, we're going to practice just the factoring part. And there are multiple times this year where we'll just factor because that's what we're going to need to cancel things out, or factoring is very important. And so these next couple lessons, if you're struggling, please let us know, because factoring is something we're going to be using all year. And so factoring is rewriting an equation, or factoring is rewriting an expression as multiplication. So anytime you see like plus signs or minus signs in between, that's not factored. But when it's separated by multiplication, then you know it's going to be factored. All right, so the first factoring we're going to look at is using the greatest common factor. So for number one, we're not factoring yet. We're just trying to pull off or retain some prior information. So it says find the greatest common factor of the following terms. So 4, 16, and 8. And remember, greatest common factor is what's the largest number that divides evenly into each of these? Well, 2 divides into each of these, but is there something larger? Yes, 4. 4 goes into 4, 4 divides into 16, and 4 divides into 8. So here, our greatest common factor is 4. For number 2, I have x squared, x to the second, and x to the third. So this is a little tricky because a lot of people are going to look at the exponents and say, well, there's only one divides into 5, 2, and 3. But remember, you're looking for what is a factor in both. So remember, x to the fifth is x times itself 5 times. X squared is x times itself 2 times. And x to the third is x times itself 3 times. So each of them have at least x times itself how many times? Well, this one has x times itself 2 times. This one has at least x times itself 2 times. And this one also has at least x times itself 2 times as well. So therefore, our greatest common factor would be x squared. So basically, when you're doing the ones with exponents, you're just saying whatever the lowest exponent is what it's going to be. All right, try number 3 on your own. All right, for number 3, this is a little tricky because you have to do the number as well as the variable. So you're looking for what's the largest number that divides into 125 and 75. That would be 25. So 25 is part of your greatest common factor. And then you also look at the variable. We have x, x to the third, x to the second. So they all have at least x to the first power, because this is x to the first, and all of them have at least x to the first. But if I said x to the second, this has x to the second, this has x to the second, but this one does not. So 25x is your greatest common factor. Again, we didn't factor yet. This was just pulling out what was the greatest common factor. As we go on to the next section, the greatest common factor, or GCF as we're going to call it from here on out, of an expression is a common factor of the terms in the expression. It is the common factor with the greatest coefficient and the greatest exponent. So again, we're always looking for the greatest coefficient. Coefficient means the number in front of. So if we look at this problem, the largest number that went into both in front, the largest factor that went into all the coefficients was 25, and then the largest variable with the exponent was just x. All right, so here are our steps for finding a GCF.
Yeah.
The greatest common factor, or GCF, of an expression is a common factor of the terms in the expression. It is the common factor with the greatest coefficient and the greatest exponent.
Yeah.
So finding the GCF is the reverse of the distributive property.
Yeah.
My son is in the background telling you, giving you words of encouragement.
Yes.
Find the largest number and or variable that is in common in all the terms.
Yes.
So that's your first step.
Yep.
After that, you make one set of parentheses and put the GCF out in front because that's going to look like distributive property then.
Yeah.
You're then going to divide all terms by the GCF and put the quotient inside the parentheses. So the quotient is what's remaining.
Yeah.
And then you always look for a GCF first. So if we look at this problem, first step, find the largest number and or variable that's in common in all terms.
Yeah.
So 25 goes into 25 and 75. So 25 is part of my GCF. And they each have at least x squared. So our first step, once we know that, is we make one set of parentheses and put that GCF out in front. So 25 goes into 25 and 75. That's my number. And then x squared is my variable that goes into both. And remember, step 2 then is you're going to divide all the terms by the GCF. So I'm dividing this by 25x squared and the second term by 25x squared as well. And it says the quotient inside the parentheses. So I started with 2 terms. I still need 2 terms because I'm just dividing. So 25 divided by 25 is 1, and x to the third divided by x squared is x. And then I have 75x squared divided by 25x squared. 75 divided by 25 is 3, and then x squared divided by x squared, that cancels out. So that is my final factored form, and you always just want to remember to look for a GCF first. All right, let's try 2 more examples. For number 1, I have 6x squared plus 9. So what number goes into 6 and 9, which is 3. So that's part of my GCF. And then also x squared and x, also they each have at least an x. So that's my GCF. Then you make your one set of parentheses, and then you divide every term by the GCF, which is 3x. So 6 divided by 3 is 2. X squared divided by x is x. Plus 9 divided by 3 is 3, and your x's cancel. And what you can always do is you can check with the distributive property. So if I'm going to check this, I'd have, here's my check. 3 times 2 is 6. X times x is x squared. And then 3x times 3 is plus 9x. So that does check. But again, this is the factored form, which is what we wanted here. And notice factoring, we said, had to be separated by multiplication. We said that up here. Factoring means separated by multiplication, or rewriting as multiplication. Notice, there's multiplication right there. There was multiplication right here. Now we know it's factored. We look at example 2. Now we have 3 terms, so now we're looking to see what number and or variable goes in all 3 of these. So what goes in 14? What divides evenly in 14, 7, and 21? Well, in that case, it is going to be 7. And then do we have a variable that goes in all 3? Well, I have y squared, y, so far, but this one doesn't have a y, so I cannot pull out a variable for number 2. Only GCF would be 7. And so then I divide everything by 7. And notice, I started with 3 terms, so that means inside my parentheses, I have to have 3 terms. Whatever you start with is how many terms you have in your parentheses, always. So I have 14 divided by 7 is 2, y squared. 7y divided by 7 is 1y. And then negative 21 divided by 7 is negative 3. And so that should be my factored form. It's now separated by multiplication. If you did want to do a quick check, you could distribute. 7 times 2y squared is 14y squared. 7 times y is plus 7y. And 7 times negative 3 is negative 21. So it does check. All right, last one we'll go over. Number 3, I have 25b squared and negative 20b. So now I have two terms. So what number divides evenly into 25 and 20? That would be 5. What variable goes into b squared and b, which would be b? I make my one set of parentheses. And now again, I have two terms to start, so now I need two terms in the parentheses. So I'm dividing each term by 5b. So 25 divided by 5 is 5. B squared divided by b is b. Minus 20 divided by 5 is 4. B divided by b cancels out. Again, if you did a quick check, 5b times 5b is 25b squared. 5b times negative 4 is negative 20b. And again, it's separated by multiplication now, so we know it's factored. All right, you're trying 4 and 5 and 6. For 4, you are going to have a GCF of 5. And when we divide everything by 5, notice we had 3 terms to start. 3 terms need to be in here. T squared minus t minus 2. For number 5, there is no coefficient or number in front that goes in all because there's a 1 in front, but there is an x that is in each one. So I'm dividing each of these by x. So inside my parentheses, I should add 2 terms because I start with 2 terms. X squared divided by x is x, and negative 2x divided by x is negative 2. And last but not least, what goes into 42 and 64? And then also n squared and n to the 4th. So what goes into 64, 42, and 64? So if you're struggling, start writing factors of 42 out. 1 and 42, 2 and 21, 3 and 14. And then 4 doesn't go in, 5 doesn't go in, 6 and 7. So now I'm seeing which of these pairs, which of the largest numbers divides in there. So I would start with my larger numbers first. Does 42 divide into 64? Nope. Does 21? No. Does 14? So if I do 64 divided by 14, I'd get a decimal, so that doesn't work. So then I would do, does 7 go in? 64 divided by 7? Nope. Does 64 by 6? It does not. 64 divided by 7 doesn't, or divided by 3 does not work. 64 divided by 2 does work. So my GCF is just 2 as my number. And then I have n to the second, because they each have at least n times itself 2 times. But my parentheses divide by n squared, or divide by 2n squared, sorry, divide by GCF. And 42 divided by 2 is 21. N to the 4th divided by n squared is n squared. Minus 64 divided by 2 is 32, and then the n's cancel out. Always look for a GCF first. Always, always, always.